Hello everyone. Welcome to Mach O Fun. My name is Derek. I'll be your entertainer for the next 40 or so minutes. Quick show of hands, because this is for my own personal amusement. How many people have never really heard of Mach O before? Don't be shy. This is kind of obscure stuff. That is awesome. This is kind of delving into the more obscure parts of Apple development, and I really think that you'll get some cool stuff out of it. There's a lot of hidden gems that can be found when you explore this kind of stuff. And I'm also kind of doing this in this talk. It's a little bit selfish too. Last year I gave a talk here on reverse engineering the springboard. And I kind of delved into all these parts of memory and didn't really talk about the theory behind it. So this is like a sort of part two, I guess, that can stand on its own. So let's talk about Mach O. Mach O is a layout for executables running on any Apple platform. This applies to your iOS apps, your macOS apps, your tvOS apps, your watchOS apps. It applies to your main executables, your frameworks, Apple's frameworks, any NS bundles, plugins, kernel extensions. This stuff is, you work with this stuff every single day. And with that knowledge, there's some pretty cool programming tricks that you can use on or against the program. Most reverse engineering people will know this format inside and out. And if you were to ever make like, I don't know, the next reveal app or something like that, having this knowledge will really help you make something very cool. So, hope you'll enjoy this talk. Let's see if this works. Oh yeah. Okay. So, this stuff is pretty complicated. I'll admit that. But I don't want you to, be on Twitter or on Slack the whole time. So here's what I'm going to try and pitch to you. We're going to talk about the theory boring part first. So, do your Twitter and Slack stuff then. I want you to not be scared of this output. It looks scary, but it's not that bad. So this is a we're in the Xcode console down here right at the bottom. This is a custom LLDB command. I posted on the Slack channel the GitHub repo for this, so if you like what you see, check that repo out. This is hunting down the foundation framework in the text setting. And this highlighted portion right here, this is where the hard-coded UTF-8 strings are stored. And we'll explore this in this app right here. So what we're going to do is look at the source code of how we can find all insecure hard-coded HTTP strings in all programs, in all modules. So everything like CF network, everything in the real model, everything everything is loaded into a process. We're going to hunt for these strings. Also in Stump, I said, hey, we're going to find curse words and frameworks. We'll also look at how to find shit everywhere and that's hard-coded in apps. Next up, we're going to look at how we can cheat at these gambling drinking games. We'll go after certain functions that are exported. So if I'm not implementing it in my executable, that generates a random number. We're going to see how we can change around random numbers without modifying the original code. And finally, if and only if I have ties that follow time management. Has anyone ever heard of this private class, UI debugging information overlay? Yes. Okay. So the story goes, there's a dude in Boulder actually, and I was attending an article about this class. It's super useful for debugging. It'll let you traverse the view hierarchy. It's great for stack comparison. So I found this class, wrote an article about it, in iOS 10. And iOS 11 now came back and added a bunch of checks as memory. So we're going to look at how we can find these areas of memory and tweak them so we can re-enable this class. Also, this is in the sample project, so these are all in that sample project we're making. So I'm not going to have you, code it out while I'm doing it, but if you want to tweak this stuff and learn how I'm doing it, that's a great place to start. Okay, so the boring part, the part where you go on your Twitters and Slacks. Let's talk about the terminology. I kind of call this, I use the word module and image quite a bit. And by that I mean anything that's loaded into the process. So again, UI kit is a module. Your app, the main executable, is a module. Right at offset 0 on disk, there's this lovely little thing called the Mach O header. Like literally at the start, at offset 0. This header is quite important. It'll tell you if this app, this module is compiled for 32-bit or 64-bit. It will tell you what the architecture slice, what the executable can run on. And more importantly than that, it will tell you the load commands. The load commands are kind of think of them as a series of variable size structs immediately following the Mach O header. They range in size, and they give you kind of an indication of how the program will be launched into memory. There are a lot of these things. There's like, I'll show you the Mach O, or I'll show you this header, but there's like, I don't know, I'd say 50 or so just in this header, and you can make your own. So it's like the Wild West. It's great. Some of the load commands will specify information on loading a segment. Think of a segment as kind of this location on disk that will say, hey, this area will have the same memory protections when loaded into the app. So for example, there is a text segment. In this segment, this will contain readable and executable permissions. So for example, your actual code will be stored in this segment. There's another common one called the data segment. This will store readable and writable code. So this is, your global variables or things that you need to change around when your program is in memory. Next up, in each segment, there can be 0 or more sections. Sections have a very specific, defined purpose. There is one particular section, as we talked about earlier, that will store the hard-coded UTF-8 strings in your app. So anything that's like, print statements or NS log or whatever you guys do, or print app if you're super hardcore, or your hard-coded HTTPS strings will very likely go in this section. This underscore text is the actual location of where your code is stored. So I said earlier, it's in the text segment, but very specifically, it's in this text section, stored in the text segment. Another example of the data with readable and writable permissions is the Objective-C class list. This is will store class pointers to each of your classes in that module. So what I'll do sometimes is I'll enumerate the section divided by the size of the pointer, and I can very quickly figure out all the classes in a framework or executable or whatever. Oops, didn't want that one. Okay. So boring part's over, and now I get to do demos for the rest of the time. All right. So let's start out with a new, and this is big enough, right, for everyone? Back there? Good? Great. Okay. I'm going to go to this lovely little header file called the Mach O /loader.h. I think I've probably read this stupid header file at least 20 times, and I still learned something new about it. There is a lot of stuff in this thing. So let me talk about the header first, the Mach header. Right at the start of your app is this struct. Okay, this is the Mach header. There's a differently sized header for the 32-bit, for 32-bit binaries, but for 64-bit, this is what you get. So I'm going to show this to you. I'm going to use XXD. This will dump raw data for a file, and I'll pick on grep. Oops, which grep? And I'm going to do something a little sneaky here, and I'll explain what I'm doing after. And I'll do that first. Okay. I'm saying dump the raw bytes to the full path of grep. I only want the first 32 bytes. Why is that? Looking at this header, this variable is a 4-byte, it's 4 bytes in size. This variable is 4 bytes in size. This variable is 4 bytes in size. All in all, there's 8 of these. 8 times 4, there we go. And I'm going to print this out, and I'll make that a little bit smaller. There you go. Okay, printing this out, kind of looks like gobbledygook. We'll talk about it. But one other important thing is, in Apple platforms, they run on a little Indian architecture. Okay, so that means the bytes are reversed on disk when I read them in memory. Another problem. I said that they were, these variables were 4 bytes in size. Each of these groupings are only 2 bytes. So there's a lovely little option for XXD called E. Oops. Oh. Okay, I'm going to do that now. And now I could easily view this mock header 64 struct. Right at the beginning, we have this lovely magic value, oops, right here, called feed fact. Looking down, we can see that this is indeed the start, the magic number for a Mach O executable. On some builds, you can have byte swapping. I won't get into that, but if you see this, then all the ordering of the bytes will be flipped. That's not the case for this, so we don't have to worry about it. Okay, next up, CPU type. We had this crazy value of 0, 1, 0, 0, 0, 0, 0, 7. How do you decipher that? You decipher it by lots of drinking and looking at the headers. So I'm going to go to jump to definition. We can see I jumped to mock machine.h. And let's keep an eye on this and compare what values there are. First up, something kind of interest is a CPU ARC ABI 64. That has this value. Scrolling a little further down, we see CPU type x86 has the 7. A little bit further down, we see CPU type x86 64. These two values are ORed together. So that's how I can kind of piece together that this was that the grep executable is compiled for x86 64-bit on my Mac. Okay, I'm going to jump back to that to the mock header and compare the rest. I'm going to skip this one because that's kind of the same exercise. You just saw what I did. The file type, right down here, has the value of 2. I'm going to scroll a little bit further down. We can see the value 2 here. It's an executable. There's a guy here from Stump that asked the question, what was it? It was a framework and simulator that's not in the app. See here? Womp womp. Okay, well, I won't answer that. But basically, I BS'd everyone and no one challenged me. But so a framework will have this value, 6. DYLD sim will have this value. So technically, I was right on the part where it's not in the actual device, but it's not technically a framework. So you could have got me on that one. Okay, next up, let's go back to the header. We just finished file type. Let's look at number commands. That's going to be 13 in hex, so that is 19 in decimal. Then the size of commands down here. I can't do that math in my head. After that, we have these flags. I won't get into that, but that's that. If you go through the header, you can see that there's some interesting ones. I think the 002, I think it's something to do with AS. No, that's a different one. Ignore what I'm saying. But yeah, they can be found in this header. After that is reserved, not used still to this day, but you know, Apple anticipated something where they, you know, we needed more bytes in our Mach O header. Okay, so what I can do now is I can do OTool minus H. This will print the header to the full path of grep. And I could have just showed you this first, but I don't think you would have really appreciated like going through the bytes and comparing the struct to what's actually happening. But as you can see, that 19 load commands of this size has the feed fact start. There we go. I'm going to quickly talk about the load commands. And I'm not the biggest fan of this output. There's much better tools out there. This is kind of too much for the eyes to read. So I'll just take a small part and we'll explore that. I said there is if a module has the C string section, that will contain hard-coded UTF-8 strings. So let me prove that to you. And I'm grabbing the information from the load command. So I'm going to grep the output of, you got it. Okay, there you go. I think I'm funny. Okay. So there is a C string section in the grep executable. I'm going to search for, what is it? I think it's 4. The 4 values immediately following it. This tells me the offset to the C string section is 14942 from the executable, and it has a size of this bad boy right here. So I will dump this information out. Offset 1492 of length, this size, with the full path of grep. Okay, we can see here that you don't care about this stuff, but you can kind of view the hard-coded UTF-8 strings here. Let me show you this another way. If I were to execute the strings command on the full path of grep, first string is standard input. Let's compare it to here, standard input. Second was, what was this? Cannot read bzip compressed file. Okay, right here. Now notice that this string did not get caught by the strings command. It's important to say that I think the default value has to be of length 4 or greater if the strings commander is going to pick up a valid string. Okay, so you probably don't really care too much about terminal commands. So let's see what we can do with your iOS apps. Okay. Oh, come on. There we go. Fortunately, I have the app already running. Visually, looks like a UI tab bar controller based upon the bottom. Clicking on that, not too exciting. Let me show you, I'm going to do a quick break and show you some of my LLDB commands to see if I can sell you on those. Then we'll go back to the actual applicable commands. But let me just, you guys will get a kick out of this. Okay, one of my commands, search. Let's search for UI view controllers. This will enumerate the heap, find every instance of a UI view controller. I can see I have a UI tab bar controller. I have, what do we have here? Mach O Fun insecure network request table view controller, casino view controller, and 2 other UI kit ones. Let's filter it out by the module, Mach O Fun. Okay. These to me look like they're Swift. Why can I tell that? Because they're preceded by the module name with the period. That's kind of the telltale sign. It's Swift. Kind of hard to do that with a class name in Objective-C, unless you're really masochistic. Let's let's look at something else. So let me prove to you that, I'll pick on this one. Use my dclass command. This will do kind of like the poor man's class dump. We can see that UI table view controller has a property, one property, of data source at offset 0x38. All the earlier offsets are taken by UI table view controller and UI view controller, going up the offset chain. Objective-C functions down here. Swift functions down here. I don't think class dump can do that, so take that. Let's see what else we can do. We can, let me prove to you that I'm looking at the right class. Let's toggle this view on and off. And you're not going to see that. Let me bring this, oops. Bring over the screen. There we go. Okay, so I found the right UI view controller, so we could comfortably say that this is insecure network requests table view controller. I'll show you something else that's kind of cool. Do this. The view is a UI table view. Let's look at the retain count. Okay, there's a lot of things holding on to this view. I can do a reverse search, so I'm going to enumerate each class and look for if any class's properties contain this pointer. So we do search -r, and again, this address right here is the UI table view. As we can see, that here are all the offsets. So we have an instance of UI swipe action controller. Here's the instance of this class, and here's the offset to this class. So let me look for that insecure network request. Got it right here. Right. So if we're to PO this, we should get insecure network request. If we were to dereference this and add 24, right, because of right there, dereference this, get this pointer, and again we have our UI table view. Okay, that's my LLDB scripts. If you like that stuff, I wrote a book about it. If not, just take them because I think they're pretty useful. Hopefully you will too. Okay, let's jump back to Mach O. I have another command called section. Section by itself will default, like no arguments, will default to the main executable, and print out all these segments. So that's pretty much the same thing as me doing the following. Same thing. If I were to drill into a segment, oops, for like text, this will now tell me all the subcomponents, the sections. Again, we have our C string section. And if I know what the type of the format is, I'll format it correctly. So there's a bunch of space. That means that there's a bunch of blank strings in here. So just a string that doesn't have anything. Let me show you. I'll get the load address of this. Right? So there's a lot of stuff that's kind of, it's spaced out, I guess. So we can filter this with, let's filter it with a regex, anything that has a valid character. And now I can finally see some strings in here. Let me prove to you that this is the case. Not like that. I'm just going to rerun it. Okay. Let me clear the screen and I'll show you this. Let's see. What's a hard-coded string? Let's look for spin. We'll do a case-insensitive search for spin. Can I do it? Oh, you know why? Because it's not hard-coded in the code. It's hard-coded in the UI table view. So that will not work. Let me just jump to, I'll just jump to the code of how this works. And then we'll put a hard-coded string in and we'll examine that. So again, we're looking at insecure network requests hard-coded into the app. I define that by any string that begins with the characters HTTP. If yes, I'll add it to the data source. We're going to look at insecure network requests, table view controller, and we're going to trigger this method. I put it in the view will appear as opposed to the did load because it's an easier breakpoint to hit. Let's look at this code. First kind of odd API that you might have not run into yet is the dyd image count. This will tell you how many loaded images there are in your process. In my particular case, there's probably quite a bit. And let me print that out as an int so you can actually read it. So there's 360 modules. So UIKit, Foundation, Core Foundation, My App, whatever. There's a lot of this stuff that gets loaded into your app. From that, I'm getting like my little happy iterator I variable. And then for each one, I'm going to go through and get the full path to the image. Oops. So I'm going to do a CPO char star. Oops. Let's do 1. And as you can see, this will bring the, this is the full path to where this executable is, module is on disk. So I'll do another one like, let's see what we get here. 8, UIKit, perfect. So this is UIKit on disk. All right, going down, this is a char star, so I need to convert this to a Swift string. After it's a Swift string, I'm going to grab the last path component. So let me look at what I is right now. I is 1, okay. So I'm going back to this value here. What base name string will do is this will get the last path component. So we can print that out. PX base name, PO, Mach O Fun. Now here's the cool API that you probably care about. Get sect data from framework. You provide it the base name string, in this case Mach O Fun, the segment, the section, and an in-out variable. This will tell you the tell you the size of this area in memory. Okay, I'm going to step past it. And I will print this out too, just so you have a reference. We're going to do text, C string. I don't want the output. I'm going to do the summary now. Okay, and I'm going to compare the variables now. So px raw data. You can see this matches with this value right here. Px raw data size. This will match with this value right here. Okay, so this is a buffer in memory of strings. So what I can do is, if you know your C stuff, you can enumerate this buffer, and if it's of length greater than 1, right, of length greater than 1. If yes, keep on going. If it has the prefix HTTP : then add to the data source. And you do that for every single module loaded in the process, and you're good to go. So on Stump, I said, which framework had the most curse words? So let's change that to contains. Do that, and then, yeah, let's do that one. That's a happy one. And let me show you that this is actually the case. And we'll add it right here. We'll say let whatever equals shit. Okay. I don't need that breakpoint. Continue. It picked it up. Come on, zoom in. All right, picked it up. Woot shit yay. It saw shit in there. Where is that? Well, oh yeah, I have a hard-coded string down here, right? And what about CF Network? Oh, I love this thing. Rapidshit.net. We have shitfest.info. We have some shit.xyz. We have shitposting.life. So I was really intrigued by this, so I was looking at references to strings and if the framework is trying to grab like any of the addresses anywhere. I'm not 100% sure, but I'm pretty sure that, or my best guess, is they just use this for testing on URLs. So you have the source code, think of your favorite curse word or body part thing, and then post it on the 360 Twitter and make sure John sees it, because you'll love that. So that's that. I totally didn't start my clock at the right time. How much time do I have left, Sam? 15 minutes. Okay, I'm going to speed up. Yeah, you know what? Maybe we'll just take it easy and we'll just do 2 of the 3, and I could figure out another way to talk about that UI debugging information over there. Okay, part 2, cheating at gambling stuff. All right, we have this horrible implementation of a slot machine, right? And we can see that if I get 3 of a kind, I win. If I don't, I lose. So let me pause for a second and do a quick little thing of theory. Okay, I have a module in my code. In my code, I'm calling an external function. Say in this classroom string. We're all familiar with that, right? Great. Okay, in this classroom string, it's loaded into a different module. In theory, this module can be anywhere, in, like any part in memory. All right, so I can't hard code this address to this reference to this function, right? And so this module that has the in this classroom string needs to be loaded first. I will be loaded second, and then I have one of 2 options. I can either try and figure out the address to this function upon load, or I can figure it out upon first call, on a lazy call. Okay? And so that brings me to 2 interesting sections in the data segment. Not lazy symbol pointer. This is a series of function pointers that will be resolved upon load. This one, which I love, this is the attribute weak reference I never shut up about. This will resolve function pointers upon first call. So we're all developers. What function do you think is being used to generate a random number? I heard arc. One of the arcs, right? So we'll start with that. I'm going to dump lazy symbol pointer section. Let's get all the load addresses to, and this is going to be a lot. So in the Mach O Fun module, these are all the external functions I'm calling. There's a lot of them because Swift can't really survive on its own, so there's all these bridging things. But whatever, let's look at something that's not, there we go. Dispatch group create. One more thing is, in my custom command, there's a plus or minus. What this is telling me is if the function has been resolved or not, meaning has this function been called before in the program's execution. Again, let's filter it and see if we got a reference to arc4. Okay. This address here is found in data lazy symbol pointer section. Dereferencing it will point to the actual function arc for random uniform. More importantly is memory region. It's in readable, writable data. Okay, let's see what we can do with that. All right, I'm going to keep that here just for reference. I'm going to create an expression, use the top level argument. This will tell me, this says, execute a command outside of any stack frame. I'm going to say returns an int, call it Derek's func, no params, return 5. Okay? Let's look at this. So there's somewhere in memory now, Derek's func exists. We can look at that right here. Okay, it's valid. We can look at the assembly. We can even make it out. It's, I know assembly's scary, but it's not that bad. Here's the function prologue. Here's where 5 is returned in the EAX return register. So it's the 32-bit register on all x86 64-bit systems, either RIX or the 32-bit EAX. That'll be the return value in a function. And then you're done. You pop off the base pointer and then return.
So that's a valid function. So we can swap that out. So what I'm going to do here is I'm going to take this. Again, this is the lazy simple pointer to arc for random. I'll say memory write the size of a pointer, this value with this value. Nothing happened. That's good. Hopefully. Oh wow! Look at the odds of that. Okay. So you can do some crazy stuff if you know where these certain sections are. An important thing to say is that unlike Objective-C method swizzling, this only happens on a per module case. Right? So if UI kit called arc for random uniform, I'd have to go in there, find the lazy simple pointer address to that to arc for random uniform and change that around. Right? That's not like Objective-C where any calls on any module, it'll change globally. And I'm proving this to you. I'm a little short on time, but this is calling arc for random uniform in a different framework. So is there a way to change this all around globally? Yes, there is. Okay, two sneaky things that you probably won't notice in this example project. Thing A is a build script. I intentionally crippled it. By the way, if you ever download stuff from the internet, from Xcode, always check the run scripts because people can do like pretty stupid, sketchy stuff in that, so just be careful, because I do it. Okay, return 0, so now the script is enabled. I'm saying create a section, interpose, in the data segment. DYLD, the dynamic link editor, will search for this area, and if it sees this, it's going to exchange around all these function pointers. So what I'm doing now is I'm declaring my function. I'm saying arc for random, swap it all out. Put this in a file called temp lols, compile it, and call it, and place it right here. All right, that's part one. Part two is, has anyone heard of DYLD, insert libraries? Awesome. I love this thing so much. What this will do is this will load the library before anything else. So right at the very beginning, I'm going to have that temp levels dlib. Everything after is going to that calls arc for random uniform. It's going to be swapped out. Okay, so again, that's an environment variable. So you can do that with any program. You don't have to recompile it. And let me show you, because that's how powerful it is. What is it? Run without building. Right? I'm not compiling anything new. This is just an environment variable I added to the program. Okay, good. And here's the other one. All right, so you know, like you could do some really good things and some really bad things. For a long time, I had the evil idea of crippling Volkswagening all my unit tests for my last company. Like, what you could totally do it because you know, everything is a reference to XC test fail or whatever, right? So what you can do is you can create a dynamic library, and it's an environment variable. So you can specify this dynamic library outside of the repo without having to do any rebuilds, and all your tests would there on how it succeed. But I didn't. I left on good terms. Okay, sorry, one last time. How much time do I have? 5 minutes. F it, let's do it. Okay. All right, so let's go up here. In the scheme section, I have a lovely little thing called UI kit injection. It's crippled some code, and now it's uncrippled. We're going to go to UIKit injection.m. I did this in Objective-C because you know, dealing with a lot of pointer stuff, it's better in C. Okay, enabling this breakpoint. Going to run this bad boy again. What's that weird stuff up the top? Attribute constructor. That's markup saying a
unloading, this method will get called.
Actually, let me show you that really quickly. If we were to look at what is it, section, this code is in a framework called A Framework. I'm great with names. And it's in the data. Where are you, dude? Okay, data. Was it here? Let me check this really quick. Oop. There you go, mod and init. Yeah. Sorry, this one right here. Okay, this is just a series of function pointers that gets called upon load. Let me show you that. That's the start address, xgx, get the info of this one. Inject UIKit core. Okay, those two match. So if you want to, if you don't like Swift and how they don't have a load method right now, like in Objective-C, the class load method, this is kind of a workaround to get that working. Okay, back to this. Let's print out UI debugging information overlay. Is this a class? Is this a class? It's a valid class somewhere in memory. Can I create it? Nope. Why? Let's look at some of the. Let's look at the reason why. PO UI debugging information overlay. Sorry, this will dump out all the methods. We can see that there's an overridden init method. Okay, I'm going to look at the disassembly for this. Only assembly for a little bit, and we're done. All right, normal boring stuff at the start. Then we have this interesting thing right here. Compare this value, which I have my commenting here. So compare this value, UI debugging information overlay, __, overlay is enabled. If it's -1, sorry, if it's not -1, jump not equal, jump to offset 130. Offset 130 is basically the name of the function. So cripple this class if this value is not -1. Okay? So I'm going to do some stuff. This is look at this code if you're interested. Don't if you're bored of it. But we're going to go right down to here. I'm going to print out this value right now. We'll do that section UIKit core. It's in the data.bss location with the filter. I think that's it. Nope. Oh, there you go. All compiled symbols will always have the underscore on it. All right, so UI debugging information overlay is enabled. Overlay is enabled. No, not right now. Let's step over this and see what happens. I'm going to rerun that command. Ooh, okay, changed that, found that in memory. I'm going to try doing that above command again. Okay. Now I can create this instance and start working with it. So there's a couple other checks in memory, that I need to augment. After that, I'm good to go. So I'm just going to resume it. And you can look at the source code for what I'm doing. So I'm adding a gesture recognizer up here. If I double tap, we can bring up this hidden class found in every single one of your apps. Every single app in the App Store, out of it is just crippled by this check. And we can, go through all the, UI view hierarchy things. We can, let's see what else we can do. It's great for IVAR exploring. I won't go into that. We could do, I really like this thing a lot, is let's say you had a designer give you a spec on, give me the exact comparison of what this should look like. You can compare it exactly and make sure that he or she is very happy and not, talking behind your back with all this. So I think I'll call it right there, but any questions? Anything? Cool, well thank you very much.